that are small and curled up, maybe we wouldn't be here in a different universe where those things were differently configured. So, so it's very interesting to consider all this, but why aren't they all extended or all curled up or some other possibility in between? So this is a question that Brian Greene is asking here, and I don't believe that we exactly have an intuitive answer for why, but it is fun to do a thought experiment of what would happen if we did have another extra extended dimension. And I think one of the things that would get affected is gravity. And if we had different gravity, would we even be here? So we'll see. Okay, so let's keep going. Let's see what Brian Greene has to say about this. So at present, no one knows the answer to this question of why the 3 and the 6. 3 extended and 6, what do you call 6 curled up small ones in the dimensions, right? If string theory is right, we should eventually be able to extract the answer. But as yet, our understanding of the theory is not refined enough to reach this goal. So we can do these thought experiments, but I don't know that our understanding of string theory is refined enough to really give us intuitive answers, okay? That's not to say that there haven't been valiant attempts to explain it. For instance, from a cosmological perspective, we can imagine that all of the dimensions start out being tightly curled up, and then in a Big Bang-like explosion, 3 spatial dimensions and 1 time dimension unfurl and expand to their present large extent, while the other spatial dimensions remain small. Wow. Hello, Eddie. Buongiorno. Good morning. How are you? Yeah. Yeah. For sure. Possible lack of verifiable predictions on the huge number of possible solutions. It can be a mess. Yes. Yeah. So for instance, once again, from a cosmological perspective, we can imagine that all of the dimensions start out being tightly curled up, and then in a Big Bang-like explosion, 3 spatial dimensions and the 1 time dimension have unfurled themselves, but maybe the 6 remain small. The 6 curled up teeny weeny ones, okay, that we don't experience because and we cannot probe because they're too small, but are needed and demanded and required by string theory in order to be a theory. Who avoids a theory that avoids big bad numbers in quantum mechanics. Hello, Eddie. Thank you. So, can someone do a super chat? That would be most welcome, most appreciated. Rough arguments have been put forward as to why only 3 space dimensions grow large. So why did only 3 space dimensions grow large and the other ones did not grow large? As we will discuss in chapter 14, but it's fair to say that these explanations are only in the formative stages. In what follows, we will assume that all but 3 space dimensions are curled up in accordance with what we see around us. So we don't experience more than 3 spatial dimensions. So we imagine that if there are 9, then the 3 are experienced and extended and big, and the 6 are curled up. Thank you, Stephen. Oh my gosh. Thank you so much, Steve. Thank you, Stephen. Thank you, Stephen, for the super chat. Anybody else who wants to contribute to super chats are most welcome to do so as of right now. Right here, right now. Go for it. Stephen is a member, yes, and he's doing a super chat. Thank you so much, Stephen. So kind of you. So in what follows, we will assume that all but 3 spatial dimensions are curled up. A primary goal of modern research is to establish that this assumption emerges from the theory itself. Third, given the requirement of numerous extra dimensions, is it possible that some are additional time dimensions as opposed to additional space dimensions? If you think about this for a moment, you will see that it's a truly bizarre possibility. We all have a visceral understanding of what it means for the universe to have multiple space dimensions, since we live in a world in which we constantly deal with a plurality, which is 3.